Welcome guys, let's start to create this assembly in our Catia software. So actually you can see isometric view of this assembly Q1, and this is the this is actually the blower assembly which is created in Catia software. So first of all we have to create this all part. Here you can see the exploded view of this blower assembly, and at bottom you can see the all dimensions and this orthographic view of the separate parts are given here. So we have to design this all part by using these 2D sketches, and we have to create assembly also for them. So actually you can see here in this tutorial you will create all components of the blower assembly as shown in figure and explode it, and then we have to assemble them together after creating this all part. And also we you will have to generate this explode view, and explode view you can see at this stage. So actually it is exploded view of this blower assembly, and next we have to create all this assembly. But before making this assembly we have to create this part in our Catia. So first of all we are creating this part which is upper housing part. So let's start to open Catia first, go to part design here. First of all we are creating all part, and then we can make it assembly. Now hide this all plane because we are not using this plane to create our parts, and create one point here which is act as origin point. Now insert axis system to this point. Let's start to create this part. So go to sketch positioning here, select this ZX plane, projected point as this, orientation is parallel to this line. Now let's start to create first of all this circle having radius value 6. But we have to create a semicircle, only half part of this circle. So go to fly out this circle and select this last one which is arc. Select this as a center from this view on the circle to this other end. Now give dimension to this circle which is 6 mm. Now make sure to complete this 2D sketch close. Now you can see this sketch is fully constructed. Now execute to sketch over again. Before going to pad, make sure to drag this sketch in part body and define this part body as a current work object. Now go to pad, select this command, make sure check this mirror extract, check what is value for this. So value for this is 8. So here we have to do half of 8, 4 mm. Now let's start to create this upper part. So go to sketch positioning again, select this as this ZX plane, projected point as this, orientation is parallel to this line, make it towards this one. Create one arc here. This like arc here we have to create here. This should be lie on this. From this to this, the center distance is 6. Actual radius value for this is 10. And next we have to create one line here from this to this. Create first of all horizontal line here, which is yes of course tangent to this line. Distance for this is actually we have to create from this. So distance from this line is present from the center. Okay, so select this as a center, and from this it is present at 8.15. 8.15. Increase this distance. Make this line first of all horizontal. Still height for this is once again same, which is 10 radius. Now you can see we have actually completed this case, but some unwanted lines are here. So to remove these lines, go to trim command, simple trim this line and this line, so we can we can check now this perfect line is created. Now it is easy to do this working first of all. Now we have to create one profile on this, so go to plane here, from select this plane type has normal to curve, select this as first curve and this as our point. Now press OK and now select this plane, go to sketch positioning, and as usual our projector point to the origin point, parallel to this line. We create one rectangle here. So we have to create one rectangle here. Now we can see a section of this. You can see a section A. Here you can see that we have to create one circle, sorry, rectangle here. The values are given as this is 4.2, this upper is 5 point, length of this rectangle is 5.75. Make this center map, this is 5.75 and from this to this is present at 10. Now it is to this sketch province because we have created this sketch fully constraint. Now we want this profile on the center core. So to create this, go to rep command, select first of all this sketch, this profile, and center curve as this. Now make a preview and you can check this part is created. Next we have to create this part. So go to plane type, select our object from plane and select this plane. We start to create this next part. So take object properly. Object value we have to use as 5.75. Now we have to create one section or one profile. So to create this section, go to sketch positioning, select this plane, restricted point as this point, orientation is parallel to this axis. Now create one profile here, so this profile you can check here. So 7.25, 5.25 rectangle we have to create. So to create one simple rectangle here, dimension for this is 7.25. So give it 7.25, length height is 5.2, and from the bottom face it is present at 10 mm distance, and make symmetrical this vertical axis. Now exit this to the sketch workbench. From here, now we have to join this and these sketches. So first of all, make this profile and height. Now you can check this profile and this profile is shown. Now go to multi-section solid from this sketch based feature and select this as first and this as second. Now make sure your closing points are exactly on same direction also and same line also. Now make preview here. Now you can check we have created this sketch. Let's move toward next. Now we have to do some select value here. So the select for this is known as 1.5. We have to do here and this go all 4 edges. Now go to fillet, select this edge, this edge, this edge and this edge, and this edge also. And this edge. So make sure you have selected all 4 edges and actual today's value for this is 1.5. Now you can check we have created this sketch. Now let's move toward next. Again go to fillet. We have to go fillet value here also. So select this edge. Make sure to select proper edge, not face. Again we have choose face. Now you can check we have selected properly this edge, and for radius value here it is given as, you can see here this is 0.5. Now let's move to our next. Actually we have to give some part thickness to this. So to give part thickness, make sure what is part thickness. Here you can see part thickness you have to give at 0.25. So to give part thickness to this, go to shell command here, select this as first phase and this as second phase, and thickness value you have to give at 0.25. Now you can check this part. This part is created with uniform thickness value, and also this part is created with hollow one inside hollow we have created this part. Now go to next all dimensions. So first of all we are creating here some flanges to support this part. So go to sketch positioning again, select the ZX plane here, projector point at this point, orientation should be parallel to this line, make all orientation proper. Now create one rectangle here, dimension height for the 6.4, total distance for this is 15. So from this to this connect half of 50 is 7.5. Make sure to coincident this bottom line of this to coincident to the horizontal axis. Your dimension is not it. Actually from here to here we have to do dimension. So to delete this from this line to this line distance is 7.5. Make up to here. And same sketch we want on other side. So drag this sketch to select all this sketches white and go to mirror command, select this vertical axis. Now you can see exactly sketch is created on this other side. Also make sure decrease this value, go here 8, go here 6. Increasing 6.5 here, 5.5 here, 5.8. Now you can think the 5.8 is perfect for this. Now exit is to the sketch following because we have created the sketch fully constant. Now is pad command here, make it mirror exchange. So this sketch command portion now make it preview here. Okay, so now you can check this part is created. Let's create some, and actually we have to remove the some material of this part at this side. So to create this, go to sketch positioning, select this to explain. Projected point is this direction parallel to this orientation. Now we have to create one circle here, semicircle actually, having radius value is 4.875. So create one, go to arc, select this and this rough sketch. And now give dimension to this is 4.875. Now exit and close this sketch. Now exit our 2D sketch for main. Use pocket command here and make it reverse direction because we want only at one direction, not in other direction. Now make it okay. And also we have to create one pole here, having radius value 1.5. So go to pole command, select this plane, ZX plane. Make sure this origin point is act as our center of this pole, and diameter of this is given. You have to do, but you can see here radius value is, so we know that the diameter is 2 times of radius. So here 1.5 is 1.3. Now you can see we created this hole also, and last part we have to create, like we have to create some holes here, which is 1 2 3 4 5 6 7 8. So go to hole command, select this face and go to sketch positioning here. And you can check that this hole is present actually, and this vertical axis is from vertical is present at 0.75 mm, horizontal it is present at 1 mm. Now exit this to the sketch for page and make sure what is diameter of this hole. So here you can see a diameter of this hole is known as 0.41, and depth value we don't want to view because we wanted this to now make it view hole. That's okay. Now we have created only this one hole on this page, but actually on this side we have to create 4 holes and on the other side we have to create another 4 holes. So to create this only by using one command we can create this. So go to transformation tool here and select this rectangular pattern and make sure to select object as this, and first the reference direction we are giving as y, make it reverse here, and this hole we want 4 instance, and distance spacing between the image 2 mm, make it bigger here, and same we want at other side. So go to second direction here, select reference element as distance axis, check what is value for this. So value for this is here to take as the total distance. So actual value for this center to center distance we have to create. So here you can see total distance is 15, and from here to here 0.75 we have to left, from here also 0.75 we have to left. So the value here is coming, but before that give here as instant times 2, spacing between the image 0.75 plus 0.75 come at 1.5. So 50 minus 1.5 is come at 13.5. So 13.5 is the center value for listening to this one. And make it to go here. Press OK. Now you can see we have created this part in our Catia software exactly look like this. Just we are changing our shading as this. So next part we have to create as in this video you can see this bottom, what we call the lower housing. Actually we have created, now it is upper housing of this floor, and now next part we have to create as lower housing. So this next part we will make in next video. So see you again guys in next video. Also we have to create a rectangle part here like this, and this rectangle from this is present at 5 mm. Actual total distance for this bottom support rectangle is 14. Make it centrally aligned. So view from vertical axis distance half of 40. Not 2, it is come at half of 40 and 7. From this to this distance is given as 6.5. So we know that the length is come at 1.5. Now we have to remove this unwanted line. So go to quick trim and select this line which we don't want. Now exit over to the sketch workbench and make sure what is value we have to give, and It is to sketch working first of all. Make sure you are in part body. You can use CAD command here and select the sketch, and value we have to be here 4 because we are using mirror constraint here. Press OK. Now we can see this lower part is done. Just you have to create some other features here. So next we have to create, actually we know the part thickness for this is 2.5. So go to shell command and select this, give here 2.5. Now we can check this also is coming 2.5. Just go to section here and take this section. So delete this shell because we are not using shell to create these holes. So go to sketch position angle, select this ZX plane. Make sure origin point, register point is this, parallel to this line, and create one semicircle having radius value at 5.75. Now make sure to close this. Now exit over to the sketch workbench and use pocket command here. Make it reverse. Make sure you use mirror constraint here. Exit, decrease from here to here. So actually we want the thickness here as 2.5 and 2.5 here and here also. So 4 minus 0.5 we have to do here. Now you can see this part is, and now make sure this perfect dimension is come here, like dimension is come here as 3.75 and now press OK. And now you can see this perfectly material is removed from this part. Now again we have to make here some pocket. So to create this we are using hole command. So go to hole, select this ZX plane here, make sure it is aligned to the origin, and we want this hole from this both side. So only one side we want to make it up to next here, and diameter of this hole, actually radius of this given, so 1.5 plus 1.5. Now it is coming as 3. Now once again go to hole command and select this face. Now go to position sketch here, align this point which is origin as this one, align this point origin this point, make it coincident. Now exit to the sketch workbench and pop radius value we have to remove here as 4.875. Now we are here 4.875 plus 4.875. Now here make up to your blend value and decrease some length. and decrease this depth value some, because we can see that this hole is removing this side of material also. So actually we don't want to remove this other side, only we have to remove this side of material. Now make it a view here. Yes, now you can see this part is created. Just some holes we have to do here. So we can check hole just given here. So go to hole command and select this face. Go to our position sketch first. Give proper dimension to this. On this vertical axis, this distance is 0.7. On horizontal axis, the value is 1. Now exit this to the sketch workbench, and actually we want 8 of these holes, and diameter of this hole is 0.41. Make it up to next year, make it view. Now we same hole we want as this set 4 and other set 4. So go to rectangle pattern here, select this hole from this current solid, and instant we want 4, and spacing between them is actually we can see here 2, and give reference element direction as this y axis. Make it reverse here. Now look at, and same we want that other side also. So go to second direction here and select here instant sense to the same hole we want other side, and reference element as this x-axis, and make it preview here, and give spacing between them we have to give as same here we can give. We know that it is 15, it is 0.75, so to 15 minus 0.75, again minus 0.75. Something wrong is come here. Plus 0.75, 1.5. So 15 minus 1.5. Actually something wrong is happening here. Just we are checking if this value is perfect or not. So this is perfect. Just check on this to this. Yes, here we are making some mistake to sketch this. So go to first of all where and check this sketch. So here we can see we have to give here 15 value. From center to this to present at 15, half of 15. Now it is perfect. As it is to this is perfect. Now I can check these holes are comes on the side. So by this we can reduce our mistakes if some mistake is happen from our side. So these mistakes happen common. So don't worry about these mistakes. Now you can see we have created this lower housing part in our Catia software. So next we have to create this called orthographic views and dimension of this lower part. So see you guys in next video to create another part of this floor asset. So let's start to make next part of this blower assembly. So actually we have done this part, this upper housing, and this second is called the lower housing. And let's start to make this next part, which is blower. The name of this part is blower. And here you can see the on top of its views and dimension of this blower. So let's start to make this part. So first of all, open Catia, go to start, part design, press it to hide this all plane, create one origin which is act as create one point which is act as origin, insert acceleration to this point. Now make sure our part body is defining our object. Let's start to design this part. First of all, we have to create two circles here. So go to sketch positioning, select this ZX plane here. Or the projector point as this. Orientation should be parallel to this, make it reverse all. And create two circles here. First is this, and second one is also going to be here. Diameter of one is 11 and the second one is 8. Now exit this 2D sketch workbench because we have created this 2D constraint sketch. Now go pad command to here and make sure what is value for this pad. So first of all, we are creating this part as this side. Just to give this, as we have to give 0.5 as a pad value. Now again select this sketch, go to copy of this sketch, paste and paste as special and this part body. Now you can check when sketch is created, and again select this sketch and go to pad here. And now from this we have to change some dimensions, so the actual total distance from 0.5 to this is 7.25. and go to here more, and we have to make it minus of 25 means 7. Here you can see we want 0.25 and give it here as a minus value. Now make it a preview. Now we can check by just click to this major button button and select this face to check our dimension is correct or not. Yes, it is 2.05, and click on this also and this also. Now check what value is coming. So it is 0.5. Now you can see that this all dimensions are correct. And let's start to create the next, but we can see that this part we want actually fully closed. So select this again, make it go to the sketch of this first pad and make this as a reference purpose only. Now you can see this is closer. What we can do, we have to this radius diameter 8 circle for reference purpose, so that this 11 diameter is come and this is fully constrained and this fully constructed one circle is created. And at this side we have to create one circle here at this section A view. You can see this circle. So let's start to create this circle. For creating this, go to this position sketch and select this ZX plane, or else you can click on this face also. Rotate context this, orientation should be parallel to this, make it reverse to align our orientation proper. And now draw one circle here having origin is as coincident at this. The point of the circle is coincident this origin, and diameter is actually I think 3. Yes, diameter value is 3. Now exit this to the sketch workbench and let's check what is pad value for this. So you can see here the actual pad value for this is 2. Now go to pad command, select this sketch first of all and give here value as 2.5, but you can see this direction is going at opposite. To make it reverse direction here, and now next we can see one hole is here. So to create this hole, just go to hole command and select this space, and let's check this hole is coincident to the center. Now it is perfect. So make sure this is we want up to 9. Next we don't have to give some depth value, and the diameter value for this hole is given as 1.5. Preview so now you can see where we have created a hole also here, which is passing through this part. And now let's move to our next to create next part. So first of all we are creating this 6 equally spaced 6 blade. So let's start to create this blade. So to create this 6 equally occupied blades, so to go to the sketch positioning, select this ZX plane here, origin as projected context. This orientation should be parallel to this line, and make it change on orientations properly here. Now exactly we have to create one circle rectangle here. So create one rectangle like this. Let's start to do dimension. So check dimension for this. So actually you can see here length of this rectangle is 2.5 and height is 20.25. So give this value is 2.5. This value height of this is 0.25, and make this bottom line of this rectangle is coincident to the horizontal axis. From this to this distance is half of 11 is 5.5. Now you can see this part is created. Just exit this to the sketch workbench of this and use add command here. Give value here as 7.25. Now we can see that we have created this part. Just again go to this sketch bar. You have to change some dimension here. So create one circle here, coincident, and make sure to do dimension to this side 11. Now go to quick trim here. Go to only trim and select this and this. this and remove this extra line from here, and again give dimension to this and exit now this 2D sketch workbench. Now you can check. Actually we have created this blades exactly and perfectly. Now this blade we want at this all circle which is equally spaced around these circles, and total number for this blade is here you can see 6. So select this blade and go to near rectangle pattern from this transformation tab and check your value. For instance we have to give as 6 because we can check here this is 6 equally spaced 6 blades. Now give reference direction of this one and make sure here we have to do completely around. Make it clear. Press OK. Now you can see we have actually created these 6 blades on which is equally spaced around the circumference of the circles. And let's move to create the next part. So here you can see we have to create some insert part also. So to create this, again go to sketch positioning, select this ZX plane and projected point as this. Orientation should be parallel to this. Now here you have to go to operation tab and select this project 3D element and select this outside radius, select this outer radius circle and create one circle as original the center of the circle, and this between these distance we have to give. Here you can see a distance given at 0.15. So give this value 0.15. Now we have to create one axis here. This axis is passing to this horizontal axis. Create once again another axis from here or somewhat here. Now do dimension to this axis from this to this. From this to this, the angle between them is given as, here you can see up to this to this is 60 and means also from here to here it is 20. So give her a value as 20 angle. Now go to quick trim command and delete these unwanted lines. Now make sure to complete this sketch because we want close the sketch only. Otherwise our pad command is not useful. So here we have completed this fully constrained sketch, and also this 2D sketch is closed one. Exit this 2D sketch workbench and use pad command here. Give here value as 7.25 and make it 2 here. Now make it OK. Now you can see we have created these blades also. Just we want same these blades on this all 6 equivalent space blade, equally spaced blade. So go to circular pattern here, select current solid as this pad 6, reference element as this y-axis, make sure you have selected complete crown and instance we are using 6 and now make it 2 and press OK. Now you can see that actually we have created this part. This properly we have to create. And in next video we are creating actually this motor 3D model of this motor. So See you guys again in next video. Welcome guys, let's start working again to design next part of this blower assembly part. So actually you can see up to here we have completed this part. Like first we have completed this upper housing, and next we have completed the lower housing, and this blower also we have completed. And next we have to make this motor part. So let's start to design this motor part in our Catia software. First of all, open Catia first. Go to start, mechanical design and part design. Give name whatever you want to do. Hide this all plane, and now create one point here to set the position. Insert axis system to this point. And let's start to create this part. So to create this part, go to sketch positioning, select this ZX plane here. Projected point as this, orientation should be parallel to this line, and make to reverse this all orientations to get a proper view. Now push up on vertical to circle here. So actually you can see diameter of this, no, so radius is given here, which is 3.50. So give radius value to this circle. So 3.50 is radius value for this. And next we have to create one line here. This line is horizontal line. Go to draw horizontal line. This the value for this is 12. Make this symmetrical to vertical axis. From center, this line is present at 6.75. Now create one line here which is tangent to this circle first and coincident to the D. So it is not tangent comes, so make sure to click this line first and this circle, and go to your function tab, make it here tangent. And once again same line you have to draw at other side also. And now go to quick frame and delete this unwanted line. Now you can see actually we have created this for the constraint sketch. Now exit this to the sketch workbench from here. Make sure what is pad value we have to do. So actually we have to give pad value as 6.5. Before going to pad, make sure you are in part body define object. Now use pad command here. Select this to the sketch, and we know that the 6.5 is pad value, so do this pad. Now let's try to create this inside part. So go to sketch positioning again, select this to explain here. Projected point is this, orientation should be parallel to this line, and make this exercise reverse to get a proper orientation here. Now create one circle here, and this circle is 3.5 actually. Exit this to the sketch workbench. Make sure what is parallel for this circle you have to do. So from here to here, to draw 9.5 circle. So go to our command now, give value as 9.5. and we have to draw one flange like a structure here. So go to sketch position, select this plane or this sketch or the face of this part and make shifted point as this parallel to this line. And go to here 3D projected element and select this 3D projected element and create one circle here and diameter of this circle actually we have to create, you can see here 10. Put 10 mm diameter in circle. Now it is just to the sketch workbench. Now use pad command here and make this reverse direction. Pad value we have to give as 0.5. Now we can measure from this space to this. It is 9.5. Now let's start to create our next part. Here we can see we have to create one hole here. To create a hole, go to this select this hole command, select this face and go to positional sketch and make sure your sketch is properly aligned to this origin. Now you can see this point is aligned perfectly to this origin. Now in order to give some dimension to this positional sketch, just adjust this to the sketch workbench and go to diameter. So actual diameter value for this is 1.5 and making up to next to it. Now you can see actually we have created one hole which is passing from this end to this end. Once again we have to create another more like construction here. So to create this, again go to hole command and select this face and ignore this error. Just do diameter value, check what the diameter value we need to put. So changing diameter, mainly we need to go here and 6. So do diameter on 6. Click here and we don't want up to next, just put a line. You can see from this to this is 0.5, so 9.5 minus 0.4 we have to get means 9 we have to do. You can see this material is removed by using this whole command here. Next move to our next. Actually we have to create this codon structure to here. So let's start to create this. So to create this, go to sketch position again. Select this ZX plane here. Projector contact this. Orientation should be parallel to this line. Reverse this on. It is okay. Let's start to create this like structure here. Let's start to create here. You can see detail value A here. Let's start to create this structure. This is first, this is second. State how much we have to create. We have to create this is 1, 2, 3, 4 whole net structure. So we have to 1, 2, 3 and 4. Now it is done. Now let's start to do dimension to this one. So this is 0.5 and this is 0.45. This also, this all also 0.45. So do dimension to this all. Setting from here to here, distance is given at 0.9. So 0.9 minus we have to make 0.5. So here it is come as 0.4517. So to give these dimensions also 0.45. Now go from this to this center distance we have to give. From this center to this value is actually 6. And from here to here also this also total is 6, so half it is come as 3. This also is come as 0.45. Now go to this projected 3D element and project this line. Nature 1, it is 1, 2, 3. Now go to quick trim command, select, remove this also, and remove this extra part also. It will be a remove some different line. Undo these operations. Spread once again by this 3D project element. again go to quick trim command here and remove this part, this. Go to quick trim only and select this and same we want that other side. Create this, select all these lines by using this drag option and go to mirror here and select this vertical axis. Now you can see exactly we have created on the side. We need to delete this also. Now just adjust this to the sketch workbench for this and check this full sketch is fully constrained or not. We don't want any black dot here. So you can see here some dots are coming. So we have to remove this all. So go to quick trim here, select this and this, select this and this. And go to arc here from the circle file, select this as a center and take this as first and this as second. Now edit this to the sketch workbench. Now check this sketch is fully constrained or not. Now you can see this sketch is fully constrained. Just here some two dots are coming. So make this also same like this other. Decrease same this value is 0.3. This from here this 0.8. Now do this some operations here. It should be 0.9 only. Now check what value this error is coming. Again same this part is coming. Once again we have to create a line from circle from here. Select this as center point for the semicircular where up to this circle. Now insert this to the sketch workbench from here. Now you can see the sketch is fully constrained now. Just go to back and select this. So here you can see some sketches are overlapped here. So here you can see if an error is coming. Now exit this to the sketch workbench. Now you can check if some black dots are coming or not. So you can see there is no any black dots, means there is no any black dots, which means our sketch is fully constrained, and also our sketch is fully closed. No any open profile is present to this sketch. Now we can move to the next part. Like go to pen, select the sketch. Now we can see we have created this sketch which no having any black dots. So you can check that this sketch is fully constrained now. And let's start to give pad value for this. So go to pad here and select the sketch. Make sure up to where we have to give pad. So from here to here we have to left some. From here to here, go to 9. Select here more. Give here value 9 minus 8.25. Now make it true here. This is minus. I can check. Actually we have created this part on this motor. And let's move to our next. So we can create this all next steps here. So actually you can see we have to create 3 holes here. So let's start creating this hole. So go to hole command, just select this face, and now go to sketch positioning, and let's start to design. So here you can see a 3x 0.75 is diameter for this hole, and which is equally spaced is given here. So first of all we have to create one circle. This circle is reference purpose only. Diameter of this is given as 8.5, and on this we have to create one circle. This point is lie on this circumference of the circle. To coincident this on the circumference, this is 0. Now exit this whole to the sketch workbench. Make sure what the diameter of this is given as 0.75 and it is equally spaced up. Now make it pure. Use here up to next only. So you can see that up to this part, this material is removed for this hole. And now make a view here and press it. Now exactly these 2 holes we want on this side. So the value we know that this is 30 and this is 90. So 90 plus 30 is 120. So 120 angle we have to make. here. Just select this hole first. So go to circular pattern here. Make sure current solid as this circle. And give here instance means how many holes we want. So actually we want 3 holes. Parameter is completely ground. And give reference narration is this. Now you can see that at 120 vibrator second and at another 120 from this third circle is click. Now make it to here. Now you can see actually we have completed this motor part dimensions, and in next video we can see the motor cover. So see you guys again in next video. Welcome guys, let's start to design a simple part in our Catia. So on the part you can see in like this isometric view of this part. Actually it is a model of motor cover. Now at bottom you can see 2D sketches of this part. Now let's start to create this part in our Catia software. So first of all go to open Catia software, go to start, mechanical design and part design. Hide this all plane, insert one point here and insert one axis system to this point, and our first work is done. We have created our own axis system. Now let's start to design this part. So go to sketch positioning and select this ZY plane, projected point as this, orientation which is parallel to this line. And actually we are creating this part. So check the dimensions for this part. So let's create a rough sketch of this, and this to this horizontal line, and change here to the arc somewhat like up to this, and go again straight up to this horizontal axis. And now let's start to give some dimension to this. So the height of this is 25. From center to this distance we have to check the diameter of this. So here the diameter of this circle is given as 70 dia. So from this to this, take some water upper side, distance from this center it is come at half of 7, and radius value of this is 10. And make sure to close this sketch to this origin vertical axis and this horizontal axis. So you can check this line is not vertical, so make this line is a vertical. Now you can see our sketch is fully constrained. Now exit to workbench and I use shaft command here, so we can create on 360 part of this. And make sure before using start, make sure you are in a part body object, otherwise this error is come like you are not in a part body object. And select shaft here, select this sketch and make sure to give axis as this Z axis, and first angle is 360. And now we are making shell to this part, so go to shell command here, select bottom face of this part, and here you can see we have to make part thickness as 3 mm. So do here 3 mm command. Now we have to create some flanges here. Here you can see we have to create some 3 flanges here. So for creating these flanges, go to sketch positioning, select this XY plane, origin at this point, orientation parallel to this line, and in visualization tab you can cut part by the sketch plane, and here we have to draw first one rectangle, and make sure to make symmetric this rectangle for vertical axis. And actually you can see, first of all, see we are taking radius value of this is 8, so the rectangle value come as 8 plus 8 is 16, and from center it is actually aligning at radius having value 85. Actually the diameter distance they have given, so from this to this it is at present at half of 85 plus the centric distance from this to this, it is 8, is 42.5 plus 8. Now make this circle to come somewhat like here, new dimension from this, so this horizontal axis, it is not coming perfectly, so delete this. Select first of all this horizontal, this, do this first, and this line. So make sure to take this 2D sketch only on this part, not outside of this part. Now you can exit the workbench and make sure what is pad value for this. So here you can see the pad value of this is given at this section. Actually here the offset section is given from this to this. The pad value of this flange is 5, and from this 14 to up, so give 5 here. Now go to make flyout to this fillet command and select a tri-tangent fillet, and make sure to select first of all this face and this face, and select this face. Now press OK. Now you can see our flange is created, and same flange we have to create at this side and this side also. So select this flange first and go to circle pattern here. Make sure at what angle we want, at 120 degree we want this flanges. So go to here, complete ground parameter, and we want the same like this 3. Select here 3 and select reference direction as this Z axis. Now press OK. Actually we have to make this circle pattern to this port also. So select first of all this tangent frame and press Ctrl and select this also. Now you can select this circular pattern, make here complete crown and reference direction of this direction. We want black dash 3. Now you can see our, we have get our exactly 3 flanges. And now let's start to create this pattern like a structure here. So go to scale positioning, select this XY plane, origin at this point. And now go to profile tab and select this elongated hole up to this and check what are the parameters for this value. So center to center distance is given here as 40 and the latest value is 3.5 from this 50. Make sure this is centrally aligned. So select this center and this center and select your allosymmetrical line. And from center this vertical line to this line, this is present as value of 18 mm. And same if you want is 1, 2, 3, 4, 5, 6 pattern. It's present at 6 mm display. Now exit the 2D sketch workbench because we have created full constraint sketch. And use pocket command here. Make it reverse the direction and choose up to next. Let's okay. Now go to rectangle pattern here and select this pocket first as a current solid to this pocket and give reference direction to this ZY and we want this 1, 2, 3, 4, 6 like this pattern. Select here 6 and spacing of this is 6. Now make it true. Now you can see 1, 4, 5. Make sure to select here as 7. Make it preview. And now you can see this 1, 2, 3, 4, 7. This also 1, 2, 3, 4, 7. And click OK here. Now you can see actually we are giving some pocket value we have to increase. So don't choose here up to next. Give some dimension. Make it reverse properly and increase some value. Now you can see our days are created properly. Actually these pockets are from more air ventilation purpose. And now we start to create this center part. So go to scale position, select this XY plane, type as this type, make this projector this point parallel to this line, and diametric value of this circle, outer circle is 25. So select center as this point, and diametric value of this circle is 25. Exit your 2D sketch workbench, and you can see from this face it is a pad value of 30. So select pad value, select the 2D sketch, and from bottom surface it is at 30 length, and go to more and select here up to surface and select this face. Getting accurate is not coming, so go to here dimension and decrease some value. Make sure you have selected proper value. Now it is perfect. And now we have to create one hole here having diameter value as 50. So go to hole command, select this face, and make sure you want this hole. To next, value of this hole is 15 diameter. Make sure this is centrally aligned. Yes, you can see this is centrally aligned. Press OK. Now you can see our hole is created, and now we have to create the same holes here in this flange also. So go to hole command, select this face, make sure. So you can see this hole is not perfectly coming at this part. So go to position sketch again. From select this and this, make it concentric, and this point is concentric to this circle. And now make sure what is the value of this hole. So hole value is actually 8, diametric value is 8 mm, and make up to next. Now press OK. Now you can see what exactly hole is come. Now same hole we want at these 3 flanges also. Select this pocket hole command and go to select your rectangle pattern. Make it complete crown here, and we want 3 same space, 3 hole, and reference direction is this Z axis. Make it OK. Now you can see our exact 2 holes are coming at this also and this plane also. Now the only one part is remaining. We have to do some fillet here. So go to fillet and select this edge, and value of this is 2 mm. Now you can see we have created this motor cover exactly in Catia software, which is shown in this part. Once again, and let's start to design last part for this floor assembly. You see like in shaft we have to create here. So let's start to design the shaft. In previous video actually we have completed this motor cover part. So let's start to design now the shaft part. So first of all open Catia, go to start, mechanical design and part design here. Actually we have opened mistakenly. Go to start again and open part design here. Now your name, whatever name you want to give. Hide this org name first. Create our own origin point and insert access system to this point. And let's start to design this shaft. create the shaft, go to sketch positioning, select this ZX plane here, projected point as this parallel to this line, create a shaft having diameter value is 1.45. 1.45. Now exit this to the sketch workbench. Make sure you are in a part ball define work sketch, work object, and use pad command here and select this to the sketch and check what is value we have to do. So up to 24 length pad we have to do. And now let's create this next part. So to create this, go to sketch positioning, select this ZY plane here, projector point as this, orientation should be parallel to this line. Now just create one small rectangle here. So let's see how can I design this part. So create a small rectangle here, and length of this is come as 0.18. Length for this is 0.18. From center this is present at 0.1, which diameter value is 1. So we have to make half of this. And from here it is present at 0.5. And make it should be coincident to this upper, otherwise give dimension from origin. Select this horizontal axis first. This upper part on this horizontal axis, and dimension for this is come as 1.45, half of this 1.45. Now we can complete this full dimensional sketch. Now just edit this to the sketch workbench, and now we are using group command here. So here we can see group, and this group command is similar to shaft, but in this group command we are removing the material from the part body by using shaft command. But in shaft command we can add our material to the body, but in group command we can remove the material of body. So now click on this group command, select this to the sketch, make sure first angle is 360, axis we have to give as this y axis. Now look at view, press OK. Now you can see this simple shaft is created by this command, and here our all part are designed. In next video we can see the actual assembly of this all part. So see you guys again in next video. welcome guys, let's start to make assembly of this part. And actually we have created this small part in our Catia software, and now we are making assembly to this. So let's start to make assembly of this part. So open Catia first, go to start here and to select assembly design workbench from this mechanical design. Now let's start to make this assembly, and this type of assembly is called as a down to top approach assembly. In this down to top approach assembly, actually we are creating the part first and then we can make assemblies of part. So actually we have completed all part of this blower assembly, and now we are making assembly as a separate part. And let's start to design this assembly. So first of all, give your name. So right click to this and go here properties and give your name as, change your name to blower assembly. Let's start to make assembly. So go to this product structure tool and select this edge stick component command here, and select again this blower assembly, and now select our part where it is part is present. So first part we have to take as lower housing here. So click on lower housing, just wait to come this part. Then we can see that this lower housing is coming, but we can check that some mistake we have done to create this part. Actually we can see we have forgot to do this flanges to this side, and may mistakenly hold to on this flange surface. Actually we want this hole at this upper part. So don't worry about this mistake. Just go to files here again and select open here and select lower housing. Make sure it is open, and you can see that now this lower housing is open as a separate partition. And now we can change this, make some changes here. Just delete this hole and now this rectangle patterns also. And now let's start to design this flanges and this on. So you can see the all dimensions here. Now let's start to create this. So to create this flange on both sides, go to sketch, select this direct plane, projector point as this, orientation should be parallel to this line. Now press OK here, and now let's start to design this. So to create this, we have to create first of all one rectangle here. Dimension for this is rest of this it is for 0.41, and it is lie on this. So you can see this sketch is already lie on this horizontal axis. So no need to give our next dimension. So just check what we have to finish up to where this part is present from this vertical axis. Actually you can see from this vertical axis it is present at 15. So from here to here it is given as 15. So half of 15 we have to do 7.85 and decrease here. Now give this dimension also from origin. Now this exact sketch we want at other side, so drag this sketch, use mirror command here and select this vertical axis. Now you can see this exact 2D sketches come at this other side by using this simple mirror command. And now exit this 2D sketch workbench from here and select pair command here and make sure to use mirror constraint here, and from here to here distance we have to give max. Which we are checking what value we have to give from this part to this, measure this distance, and from total distance here it is come as 8, means here we have to give 4. Now let's try to do this hole to this parts. So go to hole command here, select this place and let's make sure what value we have to give. From here it is 0.75. Go to the position sketch, from this it is presented to 1 mm. Side it is presented 0.7. Now you can check this point is fully constrained down. Now exit this to this sketch workbench from here and now make sure what is value for this hole. So the value for this hole is given in 0.4 is into diameter value, and make it up to next, make it up to press. Now use rectangle pattern here and make sure to select current solid as this hole. And first direction we are giving as this y-axis, and second direction we are giving as this x-axis. So for first direction we want 4 instant at this side and we get reverse other side. Second direction instants are 2. Now first spacing between them we have to give as 2 here. For second we have to do 13.5, which is correct. Place over here, and now you can check that this part is created will be constrained. Now you can check this part is created perfectly without any mistake. We have created now this part correct, and you can save this part. Just save and close this. Now you can see in this assembly workbench also this same part is correct. And now let's start to make assemblies of this part. Here you can see in this video this lower housing should be fixed, so make this fixed by using this command. Select this fixed component and select fix this one. Now insert our second part. We have to insert the upper housing of this part. So select upper housing now. Make it automatically here and press OK. You can check now you can check this part is come exactly to this part, but we have to give dimension to this also. So let's move this part some more here and here. So go to manipulation here and select this part, select this somewhat here. Drag this part somewhat offset to here. First of all, I have this plane because we are not display. And now go to coincidence here. Select axis of this. The axis is not coming perfectly. This axis is coming. We have to select perfect this axis. Now we can choose correctly to this axis, and now select this axis for this lower house. Actually wrongly we must click. Now make this coincident perfectly. Now just go to again manipulate, select this part and select here is a Z axis. Drag this component back some upward side. Go to here contact, select this and make contact. Actually we have to make contact of this. Contact of this part to this. And now check how much degrees of freelance are remaining to prox, means remaining to restrict of this part. So go to the art object here, select this component, degrees of freelance. Now you can see here only one is remain, which is translation in y-axis. So to remove this, use angle constraint here, select this image and this below part, close this, go to your offset, select this image and this value here, hit save, press OK. Now you can check is there any degrees of freedom remaining to this component or not. And now you can check there is no degree of freedom to this upper house. Let's start call the next part. So go to existing component, select this blower assembly. Now select this blower part here, you name whatever you want to name it, and go to manipulation and drag this component in y axis. Press OK here. Now go to coincident here and select axis of this. It should be coincident to axis of this. Go to contact constraint here, select this as per face and this as second. And now just check what are the degrees of freedom remain to me. So only one is remain, and this is in this y-axis rotation is there for this component. So to restrict this y-axis, Go to angle constraint here. Check YZ plane of this component, lower first component, and this normal parallelism here and press OK. Now go to again this part, and now we can check how much degrees of freedom is remaining to this. And now you can check there is no any degrees of freedom for this part. And now let's move to our next part. So go to existing part now. Now we have to take shaft here. As you can see, this shaft should come at some to the upload. Here see how this shaft we have to keep. Make it auto rename here. This set is coming because of we have give all part name as same. Here you can see this part name is part 1, 2, 3, 4. That's why it is coming like that. This all part have same name. So actually we have to change the name for this part. So when we are clicking this automatically name, this software makes some software give their own name to this part, like this part 1.1, part 1.2, part 1.2.3. Like this status software is giving name to this part. And go to our next, go to again coincident here and select axis of this shaft and axis of this hole to fully coincident. Now also we have to make contact to this. Select contact here, select this place and this place. Now you can see this part is done. Let's check is any degrees of freelance is remaining to this part or no. So make right click to this part and just go to the part of here to components to this. Now you can see one rotational is here. So to restrict this y-axis rotation, we have to go angle position. First of all, go and select this yz plane of this shaft and yz plane of this fixed part, which is lower housing part, and make here parallelism. And now you can check this all the piece of freedom is restricted to this shaft part. So some errors coming, it means that there is no any degrees of freedom to this part. And now let's start to move the next part. Last we have to play. Go to again constrainting existing component, select this power assembly and call this motor part here. Make it auto rename here, because the same names are coming. Now go to manipulation here and select this part and move this part somewhat like here on the and now let's start to do the animation to this part. go to context constraint here first. First of all, go to coincident, what we call it coincident constraint, incident axis of this shaft should be coincident to axis of this. Now go to contact here. Now go to this contact constraint, select face of this shaft and face of this. But we can see that here it is coming upside down. Select this offset constraint and select this face once again, and now select this face. And now we have to choose some dimension to make this coincident. So choose here value at 0 and check what is coming here, and now you can see this is coincident to this. Increase some more length. And now press OK. Now we are checking how much degrees of freedom we have to remain to restrict. So we can see only 178 So again restrict this y axis rotation. Go to the angle constraint and make sure to select YZ plane of this motor and YZ plane of this fixed means this lower housing, and parallelism here. Now press OK. And let's check again, is any degrees of freedom is remaining to this part or not. Now we can see this thing is coming. This means all degrees of freedom are rest. Now one last part we have to constraint here. So I can go to existing component, select this blower assembly, and call motor cover here and press OK. Make it auto name here. Now you can see that this motor cover is come at the inside of this. So select this cover and go to manipulate and drag this in y-axis. You can see this is dragged somewhat in y-axis. Drag up to here. So now you can give dimension to this easily. Now go to again coincident constraint here and select axis of this. It is coincident to the axis of this shaft. And again go to coincident constraint and axis of this hole should be coincident axis of this hole. Now again coincident this also. But there is coming error, and this error is about this part is already fully constrained. Now drag this, we have to drag this to here. So go to manipulation, drag this component in y-axis. Now use contact constraint here, select the face of this flange and this flange. Now you can see this is perfectly coincident to this part. Just check is any degrees of frequency is remaining to this part or not. So right click to this part, go to part of checking and check component degrees of freedom. And now you can see there is error is coming, like there is no any degrees of freedom to this part. Let's OK here and add this all constraint hide this axis also. Just go to tool here, hide this all origins point. Now you can see this lower assembly is completed in this Catia software assembly workbench. Now you can see this exactly assembly which is shown in this video. Means we have created this assembly perfectly in our Catia software. So the video is ending here. Thanks for watching this video.